Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on December 21st, 2025, about 3 days ago. This paper introduces MemEvolve, a meta-evolutionary framework that evolves not just an agent's experiences, but also the memory architecture itself. And it reports improvements of up to about 17% on agent frameworks like Small Agent and Flash Searcher. The paper is titled MemEvolve, Meta-Evolution of Agent Memory Systems. And as we'll see later, the big story is how these evolved memory designs transfer across tasks and even across different backbone models. Figure 1 makes the core claim concrete, because the meta-evolved memory wins across multiple agent benchmarks. The full set of bar charts in Figure 1 compares accuracy across 3 tasks, with MemEvolve highlighted. In XBenchDS, MemEvolve reaches about 74%. In WebWalker QA and Gaia, MemEvolve also leads the pack, landing around 75% and 73%, while no memory stays closer to about 71% and 69%. Figure 2 gives the intuition for why meta-evolving memory matters, because it frames agent learning like human learning. The full diagram contrasts 3 regimes: mediocre, skillful, and adaptive. The mediocre side basically discards past attempts, while the skillful middle keeps an error notebook plus reusable tips and tools under a fixed scheme. The adaptive side goes further by changing how experience gets consolidated, producing solution templates and reusable insights that keep improving. Table 1 shows that self-improving agent memory is not one trick, but a mix and match of 4 parts: encode, store, retrieve, and manage. The full table maps 12 systems in Evolve Lab so you can compare their design choices side by side. The left columns summarize whether a method is single agent or multi-agent, plus whether it remembers whole trajectories or individual steps. The right columns show common patterns, like vector databases for storage and semantic search for retrieval. Figure 3 explains how MemEvolve upgrades memory by evolving both the stored experience and the memory design itself. The full diagram lays out the search space, which breaks memory into encode, store, retrieve, and manage so the system can swap parts in and out. The middle flow runs multiple candidate memories across iterations, and it keeps the ones that do well on success while controlling token cost and latency, so evolution is multi-objective. The right panel shows a diagnose and design loop that turns failure logs into targeted architecture changes. Table 2 makes the practical point that memory design can move agent benchmark scores in a measurable way, not just in toy settings. The full table compares many closed-source and open-source agent frameworks across WebWalker, QA, XBenchDS, Taskcraft, and Gaia. The lower block highlights MemEvolve variants, which improve Flash Searcher to about 74% on XBenchDS at pass at 1. That same block also shows cross-model runs on Kimi K2 and DeepSeek v3.2, so the gains do not depend on a single backbone. Table 3 shows that the evolved memory is not just more accurate, it can be competitive on practical overhead like cost and speed. The full table compares memory settings for Flash Searcher across Gaia, XBench, and WebWalker QA, and it reports performance alongside API cost, latency, and step count, so it is a trade-off view. MemEvolve leads on accuracy for all 3 tasks, and it keeps costs in the same ballpark. MemEvolve also posts the lowest cost on WebWalker QA. Alright, 2 takeaways stand out. First, letting the memory architecture itself evolve, not just the stored experience, delivers solid accuracy gains, topping out around 17% in some agent setups. Second, those evolved designs transfer across tasks and even across backbone models without blowing up cost or latency. That points to a more automated path for engineering agent memory. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.